Good morning, scholars. So, we are in Oceans, Atmospheres, and Climates. We're in Chapter 2, Lesson 2.1. And so, we're going to start with our warm-up. Right? So, it says, find the place where you live on the world map and estimate its latitude. So, I'm going to look for the continent that looks like North America. We see South America here, so we know this continent here. It's North America, and if I'm estimating, we see Florida move on up. So I would say that New York's around 40 degrees north, right? Like that's the latitude of New York. It's around 40 degrees north. So based on the latitude we estimated, predict how much energy is being transferred from the sun to the surface and then to the air. So how much energy is being transferred based on where we are. And then you're going to also answer, other than latitude, what else do you think might affect the air temperature where you live? So you're going to answer those two questions, and you're going to hand it in, and then we're going to move on to a reading. But before we do that, Ms. Jackson wants to review some things with you guys. So far we know that a location's air temperature is affected by its latitude. And we know that latitude is the distance from the equator, right? And we know that the closer this distance is to the equator, the more energy it receives. And since the city's latitude doesn't change, we know that there's another factor we have to consider. So when we're looking at El Nino years, we saw that the temperature is changing, but Christchurch doesn't move. So latitude can't be the only thing that's changing, that's affecting the temperature. So we know that air temperature is an effect, right? The location, air temperature is an effect. We talk about what determines the air temperature. And we want to look at some of the causes. So we know that latitude affects the location, air temperature, but it doesn't explain this problem with El Nino. So we have to find the other cause that could change, that can determine a location's air temperature. So that brings us along to a key concept of cause and effect. An effect may have more than one cause. These may be linked into a chain of causes and effects. So scientists explain events that they observed in the natural world. And in order for us to explain these events, we need to investigate what causes them and how they may be linked. So for example, when we're looking at plants growing, right? There's a lot of things that need to happen for a plant to grow. We need sunlight, we need water, right? We need nutrients, and that can come in the form of soil or something we add to our water. But there's different things that cause the effect of our plant growing, right? There's different things that cause our plant to grow. So same, when we're exploring what's happening with air temperature, we're looking at all of the causes that make this air temperature location change. So let's go on back. We are going to be reading an article today called The Ocean in Motion. And we're going to be reading this article to answer the question, what makes the air temperature change, right? So remember our active reading guidelines: to think carefully about what you read, to pay attention to your own understanding as you read, to annotate the text to record your full thinking, to highlight challenging words, examine all on visual representation. And we can't discuss our work right now, but what we can do is discuss it maybe with your family if you want to. Okay, so now that we reviewed our active reading guideline, we are going to go to the article. Hold on. There we go. Ocean in Motion. So once you click on that link to the article, it should take you to this page, The Ocean in Motion. So let's start with the title. So I'm reading The Ocean in Motion, but I'm seeing, as I look here, I'm seeing pictures of shoes. And so, that gets me wondering. I'm seeing all these people pick up shoes, and it looks like they're doing it on the beach. So I think that these shoes were in the ocean and they washed ashore. So this makes me ask a why question. Wait, why would there be shoes in the ocean in the first place? These shoes must be connected somehow to the ocean's movement. Okay, so I'm going to start reading my first paragraph to figure out how this is connected. So I'm seeing that thousands of shoes fell off the ship that was carrying them across the ocean. Oh, okay. Eventually, some of those shoes washed up on this beach, and people collected them and tried to find matching pairs. So, surprising things sometimes wash up on shore, and this can happen all over the world. During a powerful storm in 1990, containers packed with 61,000 shoes fell off a cargo ship traveling across the Pacific Ocean and eventually washed up on the beaches in Oregon, Hawaii, and Japan. So this has me thinking, how? But we know that how is not specific enough. So let me think about how to make this question more specific. How did those shoes wash up in these different locations? So I'm going to make my first note here. And I'm going to write, how did these shoes end up in different locations? I'm going to hit save. And once you hit your annotations and you hit save here, not only can you see these later on when you go back to the article, but Ms. Jackson can see your annotations too. So remember that you're getting graded for your annotations. So let's think about a deeper question. So these locations are hundreds of thousands of miles away from the place where the shoes were spilled. How did the shoes make their way in these locations? So, Ms. Jackson's just going to model making deeper questions, and I'm going to scroll down to a map really quickly. So, there's a map of the oceans and currents of the world. Boom. Right? So, here are the ocean currents from 5 major gyres or circles. Right? And that's the Indian Ocean gyre, the North Pacific gyre, the South Pacific gyre, the North Atlantic gyre, and the South Atlantic gyre. Right? So we're seeing these over here. And so as we look at these maps in the article, you want to look at them and ask some deeper questions. So I'm looking here, and there's a lot of lines here, right? And so I'm wondering what these are. But before I even make that annotation, I'm going to check my key and make sure that there's not something that tells me, right? So if I look at my key, it tells me that the red arrows show a warm current. So these red arrows are showing me warm currents. And these blue arrows, they're showing me cool currents. Right? So instead of asking a simple question that the key answers, I can ask a question that will help me get an understanding, right? A deeper question that will help me understand more. So maybe I'm thinking, why are there warm currents and cold currents? So I'm going to add a note here, and I'm going to say, why are there warm currents and cold currents. Right? Why does this occur? I don't know. You guys have to read and you'll tell me more about it. So, now that you got an idea of what this looks like, right? What I'm expecting for your annotations. And remember, guys, that you're going to go and annotate and read the whole article. I know Miss Jackson just read the first paragraph and annotated one image, but there's plenty of images for you guys to annotate, and there's plenty of paragraphs. So once you knock that out of the park, shout out to you. We're now going to not do anything with the discussion because we unfortunately can't see each other, so we can't discuss. But one thing I do want to talk about is this new word, and it's ocean current. So ocean current is the ocean water flowing in a continuous path. Right? So if we look, we can see the water is flowing here. Let me start somewhere at the beginning. You can see this water is flowing here and then flowing out over here. And if we just think of this kind of the globe, right, we're going to have to loop around, right? And so it's going here. So these continuous paths that our water is flowing, those are called ocean currents. So if you have your notebooks, I would get that definition down. And that's the only thing we have to do in our student discussion because there is no one to discuss with. What you can do is rate your active reading skills. So as you read, did you pay attention to your own understanding and record your thoughts and questions? Well, Miss Jackson did it sometimes, right? Because I didn't read the whole article. But you guys are going to read the whole article and you're going to be honest. So you're going to honestly pay attention and record my thoughts and questions. And then you're going to hit hand in. And so, boom. So then Miss Jackson knows how you felt about how you annotated this article. And then I can also see your annotations. So if you look here, this is what it looks like for Miss Jackson. I can see your annotations. I can click on it. I can see your notes and everything. So the last thing I want to cover before we leave here is what your homework is for today. So we're going to open the oceans, atmospheres, and climate simulation. And we're going to make sure that we're in current map mode. So our mode is current map. And we want our temperature view to be none. So we're right at the right speed. And we're going to find a current that would be part of a gyro. So let's hit play for a minute. And then if I'm looking, I can see that these are kind of moving together in a continuous path here. So Miss Jackson's going to follow this current. And I want you to activate the tracking system just like Miss Jackson did. And you're going to draw this path on your student worksheet. So let me pause here so you guys can see what that looks like for you. So you have this sheet and you can open it either in Google Docs or you can use a PDF editor like Miss Jackson is doing now. And what you're going to do is you're going to draw the path that you traced on this sheet. So if you look, Miss Jackson is going to go back to her path, and we're looking and we're seeing how that current is kind of moving in a circle and going up and down and around, right? So this path that I'm following here, right? I'm going to draw this on this sheet. So I'm going to draw this on this sheet using, like I said, you can use a PDF editor. You can open it in Drive, you draw it, and you're going to answer these 3 questions. So you're going to describe the shape of the path you track. So Miss Jackson's shape was kind of circular, right? I saw that mine was circular, then it kind of went up a little into an S. But for the most part, mine was a circle